For the final segment on looking at the labor-demand relationship, let's consider some of the behaviors of profit-maximizing firms. We'll take a look at the condition in microeconomics of marginal revenue being equal to marginal cost and consider how that relates to labor as an input to production. We'll consider this balance condition that we've talked about once before as a profit-maximizing condition. And then we'll look at the relationship between the marginal revenue product of labor and the marginal expense of labor. Separately, marginal expense of labor and the wage. And then finally, what that has to tell us about marginal revenue product and the wage itself. Let's consider first marginal revenue and marginal cost. Recall for a moment that if we have a goods market, let's say it's for shoes, with a price and a quantity, and this is the market. This isn't for a particular firm. This is the entirety of the market. We have a supply and a demand. It's going to yield some P star, and it's going to give us some Q star. That if this is the market clearing price for shoes in this market, then every firm selling this shoe in the market must sell the shoe at that market clearing price. If it tries to sell it at a higher price, then it won't be able to sell its goods. If it tries to sell it at a lower price, it will sell more of them, but some other supplier will not be able to sell theirs, and there's no reason for it to sell at a lower price. So if we think about it then, as we change the number of units, the price does not change. Marginal revenue is equal to a change in total revenue divided by a change in quantity. And marginal revenue would be constant at P star such that marginal revenue is not changing if this is in this market where P star has defined what we have going on here. Well, all right, so we understand that. We understand we're going to have a constant marginal revenue. So let's just bring P star along here, and we'll call this marginal revenue. But we're also going to remember that it's P star. Well, what does marginal cost look like? Well, marginal cost, even in a competitive factor input market, is likely to experience some rise such that we have a increasing slope for marginal cost. This is because of the law of diminishing marginal productivity, such that we're going to have some confluence of marginal revenue and marginal cost, and this is the quantity that producer is going to want to manufacture. Well, if we think about it, marginal revenue and marginal cost are simply contributions to revenue for the firm and contributions to cost for the firm. Can we think about this with respect to labor? Well, certainly we can. And we'll think about this when we talk about marginal revenue product of labor and when we talk about the marginal expense of labor. The marginal revenue product of labor, as we will recall, is simply labor's contribution to the revenue structure of the firm, and the marginal expense of labor is simply the labor's contribution to the expense structure of the firm. So profit-maximizing firms are going to choose to manufacture a quantity of goods at the point where marginal revenue equals marginal cost, such that on the next unit, if they manufacture one more, they would actually lose money. So they want to stop before they begin to lose money. They've been accumulating profits, even though it may have been dwindling on a per unit basis. At the point that it reaches zero, marginal revenue equaling marginal cost, so there is no marginal profit, that's where the manufacturer, the producer of the good, wants to stop. Well, let's think about this from a different standpoint. We're thinking about labor and its relationship to other input goods and how we might consider these together. Let's assume that we have two factors that we're using in this relationship. Let's say we're using labor and we're using capital. And we know that the firm is trying to reach a balance condition with labor and capital, and we've already talked about how the firm can easily make adjustments to labor in most production environments and can do so in the short term, but capital, harder to make adjustments to. It takes time to make adjustments to capital. So we're going to think about how the firm might reach this balance condition. We actually looked at this once before, and we're going to think of balance condition including the marginal product of labor divided by the price of labor. And recall the marginal product of labor is simply a change in quantity of output divided by some change in labor units. Similarly, the marginal product of capital, which we'll have to consider in just a moment, is a change in some quantity of output units divided by a change in some units of capital. So we're looking for a relationship that will give us an equality between the marginal product of labor divided by its price and the marginal product of capital divided by its price. If we think about this, this would actually reveal itself through a relationship that might look something like this. If we have the price of labor and the price of capital yielding some kind of a budget, and we have some kind of a preference or almost a indifference curve relationship for a firm that was motivated by these marginal products. This looks a little bit like the consumer optimization that we might suppose, but in this case, this will be a ISO curve, and this will give us some ISO quant, and this would be our budget, or we might think of it as an ISO cost or even ISO profit curve. And at this point, they're exactly the same. Well, if we think about it, this budget curve that we've identified here is simply informed by this relationship that we know of as the marginal rate of technical substitution, which in this case is going to be PL divided by PK. And the ISO quant in this case is going to be informed by marginal product of labor divided by marginal product of capital. That's going to inform us of our ISO quant. And we can get those from this balanced condition relationship by simply rearranging this algebraically such that we have marginal product of labor divided by marginal product of capital being equal to the price of labor being divided by the price of capital. So when we rearrange it like this, what we're seeing in the iso-quant relationship is these marginalities, and what we're seeing in the budget relationship are the prices. Well, we can accept that, so we can kind of visualize what this relationship looks like. It's not foreign to us. We've seen this in other consumer relationships. We'll see it again as we talk about labor supply. But let's think about how the producer would go ahead and start to change this relationship if our equality became an inequality. Let's assume that we actually had marginal product of labor over the price of labor being less than the marginal product of capital over the price of capital. Well, we know that the firm, if it's only one firm using labor and one firm using capital and an entire market of labor and a market of capital, the firm is not a price setter for labor and it's not a price setter for capital. It can't change those values. If it is a price taker, it has to pay what the market is charging for those goods, otherwise it can't buy the goods. And there are numerous other users, consumers of those goods in the market. And we know that to change the marginal product of capital, we need to change the amount of capital that we're using. Well, as we increase the capital we use, then we decrease the marginal product of capital, or similarly, if we decrease the capital we're using, we're increasing the marginal product of capital. This is very similar to marginal productivity of labor, marginal utility, etc. But because we can't change the amount of capital we use in the near term, it takes time, planning, expense, etc., we have to think of marginal product of capital, just like we think of price of labor and price of capital, as being somewhat fixed, certainly in the short term. In which case, the only element in this relationship that we can change is the marginal product of labor. And if the marginal product of labor over the price of labor is small by comparison to the marginal product of capital relationship that we have, then we need to find a way to increase it. We need to increase the marginal product of labor. Well, how do we increase the marginal product of labor? by decreasing the labor units. So if we yield a decrease in the labor units, it's going to yield an increase in the marginal product of labor, in which case we may then be able to bring this into an equality. So this is a balance condition, and the balance condition is going to look a little bit like the graphic that I've got over here on the right-hand side, but this is going to be a condition that really tells us we're utilizing each of our inputs efficiently. Let's think about another way of considering this. This is another profit-maximizing behavior of a firm, and this is where we have some relationship where the marginal revenue product of labor, which recall we've already looked at this and identified that this is really no different than the labor demand curve in a competitive market for labor, where this is going to have some equality of the marginal expense of labor. Well, let's assume for a moment that this is a competitive market for labor, and that this one firm, which we're looking at the moment for the firm, is subject to labor price from the entire market of labor. This is the market where we have labor supply, labor demand, labor, and wage that's yielded us some W star and some L star for the marketplace. But this firm is only going to be using its part of L star, but if it's buying labor from this market, it must pay W star. So regardless of the quantity of labor units, then it's paying W star. So in this case, we would think of W star here, and we would think that it is also equal to the marginal expense of labor. Recall that the marginal expense of labor is equal to a change in the total cost of labor divided by a change in the labor units. Well, how might we think about this? If we find that we have this relationship, it's going to give us some, let's say, L prime, because this is a point at which the marginal cost of labor, or marginal expense, same thing, marginal cost and marginal expense, same thing. So the marginal cost of labor is equal to the marginal revenue product of labor. This is nothing different than labor's contribution to revenues being equal to labor's contribution to expense. And in the marginality condition, we want these to be equal. Or we at least don't want to use a number of labor units, we'll call it L plus, such that we are at a point where marginal expense is greater than revenue. Because anytime expense is greater than revenue, we are losing money, and we never want to plan to lose money. Similarly, we don't want to only use L negative, because yes, we are in a situation where revenue is greater than our expense here, but we're leaving some profit on the table, because we could be manufacturing more units if we are using more labor, and we could be capturing some of this profitability that exists. Well, in this relationship, we have to think about if marginal expense of labor is equal to marginal cost or marginal revenue product of labor, is marginal expense of labor necessarily fixed at the wage? Let's look at a situation where it might not be, and then let's come back to think about where it is. Let's assume for a moment that we're going to think about a marketplace of wage and labor that's going to be informed by a labor demand relationship of 20 minus 2W, such that I can think of wage, labor units, total cost of labor, and marginal expense of labor, which we recall is simply equal to a change in the total cost of labor divided by a change in the labor units. And in this relationship, if the wage we're dealing with is 0, or $2, or $4, $6, $8, and $10, that would give us then labor of 20, which is simply going to be, the labor is going to be 20 minus 2 times 0, the wage. Or if it's $2 wage, 20 minus 2 times 2, so 20 minus 4 is 16. And then we have 12, 8, 4, and 0. Well, what's the total cost? We know the total cost is going to be wage times labor. So TC equals wage times labor. And so here the total cost is 0. And then we have a total cost of 32 and a 48, again a 48. Now I believe we have once again of 32 and once again of 0. So what's the marginal expense of labor? Well, it's undefined in this first because we don't have anything we're changing from necessarily. But here we have a change in total cost of 32 divided by 4 units of labor. So 32 divided by 4 is going to give us a marginal expense of labor of 8. And then we have a change of 16 divided by 4, so marginal expense of labor of 4. And then a change of 0 divided by 4 is 0. And a change of 16, now it's negative 16 divided by 4, so negative 4. And then we would see negative 8. So we see that the marginal expense of labor is decreasing as the labor units are decreasing. So they are positively correlated, and we would see that that has some kind of a upward slope, because if they're decreasing similarly, that means they're increasing similarly. So we have a positive slope. And we can think about if there's some marginal revenue product of labor relationship that looks like this, that we would find that in this case, we have some marginal expense and marginal revenue product of labor here, yielding some L prime. But what if the labor supply relationship here was such that it was less than marginal expense of labor, and let's say it came through something like this? Well, we're going to be hiring the number of workers based upon the marginal expense and marginal revenue relationship, just like marginal cost and marginal revenue. But we're not going to have to pay them the value here, which I will call W prime. We're going to pay them W negative, because if we're looking for L prime number of workers, when we subject that to the labor supply curve, it yields the necessity to pay W minus or W negative wage, even though we might be able to afford to pay W prime. Well, how would we be able to exist in this kind of relationship? Only if there was some leverage that producers had over this market, and would have that leverage if there is some kind of a monopsony or some kind of market friction. Maybe there was only one consumer of labor, one employer for this type of labor in the entire marketplace. So this would be a situation in which the wage, W minus, is less than the marginal expense of labor. So this would clearly represent some type of market friction. However, if we came back to our relationship where we thought of marginal expense of labor being equal to the wage, as we've suggested that we're going to get to, then that would suggest that the wage would be constant regardless of the number of labor units, and that would be the condition of a firm that is employing labor in a market where there are many employers of labor, such that regardless of whether the firm wanted 20 labor units or 4 labor units, it was simply subject to some value. So you would have this wage relationship, we'll call it W prime, and we've got some marginal revenue product relationship, and no matter how many workers the firm wanted to hire, it had to pay W prime because it's in this market. Well, this would be its marginal expense of labor, wouldn't be changing, and it would yield some L prime number of workers at the confluence here. But we now, instead of having an upward sloping marginal expense of labor relationship, we have a constant marginal expense of labor relationship, and the difference being that in this case, this firm has some monopsony or producer power over the market, and this firm to the right is one of many firms in the marketplace, and it simply must pay W prime regardless of how many workers it's hiring. Well, in that case, you just saw that we can have a competitive market solution such that marginal revenue product of labor was equal to our wage, and that was also our marginal expense of labor. And this then is a competitive market condition, whereas the marginal revenue product of labor being equal to the marginal expense of labor is a general market condition that can explain a competitive market, or it can explain a friction market, or a market with some producer power or power asymmetry built into it.